Welcome to the Alliance for Water Efficiency's video on downloading and entering weather data into the sales forecasting and rate model. Users of the sales forecasting and rate model are required to enter weather data in order to use the simulation module. Weather data are entered on the Step 6 Enter Weather Data worksheet. There are two different types of weather data that are entered. First, monthly precipitation totals, and second, monthly average maximum air temperature. So we get a lot of questions from users on different sources for weather data and problems they encounter in organizing that data and then getting it entered into the sales forecasting and rate model. So we decided to do a quick demonstration that shows you one way you can go about this. There are a lot of sources for weather data, and you may have a preferred one that you use for planning purposes. And we recommend you stick with whatever you find to be reliable. And of course, you can always compare different sources to see how they line up. For this example, we'll use the NOAA website and show you how you can download the data set that you need, reorganize it, because of course it doesn't come in the perfect format, and then how to get it entered into the sales forecasting and rate model. So if you use your favorite search tool and enter NOAA weather data or some combination of those words, you'll find the National Climatic Data Center, which is a NOAA website. And if you click on Climate Data Online, you'll be taken to the website we need to download our data. Now you might notice this yellow bar here with the warning, and it says they are planning to discontinue the monthly and annual summary products. And this does affect us. I typically use the monthly summaries, and they're no longer going to be available after September 30th. However, it says this information will still be available through the global summary products. So for this example, we'll download a global summary data set. The two are very similar. The global ones have a bit more that you can choose from, but you can just select to download the temperature and precipitation data that we need, and that's all you'll end up downloading. So we'll, without further ado, go on through this process by clicking the search tool. So there are, again, not only a variety of services that provide weather data, but within this service, there are many different ways to get your hands on the data you want. But for this example, we'll go ahead and use the search tool. And the first thing we have to do is select a data set that we want. And this is where the monthly summary is what I've used in the past, but it's no longer going to be available. So we'll click Global Summary of the Month because we need monthly data for each of the years we're going to choose. And then we select a date range. The sales forecasting and rate model will take up to 90 years of weather data, and it recommends a minimum of 15. For simulation purposes, I prefer more data the better kind of approach. And for this example, just for example purposes, we'll go back to 1980. So for our start date, got a little aggressive on the scroll there. We'll go to 1980. We want the whole year and every month, so we are going to click on January 1st. And for our end date, we'll go through 2015, and we want the whole year. And so we'll click on December 31st. Now this is something I want to point out. If you haven't used this website, you might see this red text that says you must click on a day in order to select. And that got me hung up a couple times because I assumed that this was highlighted blue, that it was already selected. So you have to click on the actual day that ends or begins the month that you're interested in. And then what do we want to search for? We can search for individual stations. We can search by zip code or cities. And if we go zip code or cities, we will get a number of stations within one data file. So I like to just get data from one station. Of course, every situation is unique, but I typically like an individual station if I can get the years I want. And then you enter a search term. AWE headquarters is in Chicago, Illinois, so I'm going to go ahead and type in Chicago, Illinois, and that'll be our search term, and we'll see what we can find. So this is churning away. It kicked up our results. It shows us on this map what stations it pulled up, and then we can also see, of course, on the left-hand side what we've got. And so it gives you the station name, and then also what's very important is the period of record. So for this example, we are looking to get data from 1980 through the end of 2015, and we can see this first option won't take care of our needs. You also want to, of course, keep in mind the location of the station. As you can see, we typed in Chicago here, but we're getting results far away in southern Illinois, and we don't just want to take something because it has our period of record. We want to make sure it's close to where we want. You can see Chicago Midway shows up as well, and it has data from 1928 through July of 2016. So that is a very complete data set for our time period. I'm also going to go a step further and see if there's a weather station for the O'Hare Airport in Chicago. And that's another thing, I'd just like to point out is that airports are often a great source of weather data, particularly, if it's close to your location and it's relevant, you might want to check an airport. They often have weather stations that have been active for a long time and will usually have a good time period available. So O'Hare has 1958 through July of 2016, so we'll add that to our cart. And then we'll click on our cart and go through the next process, which is just to make a few selections before we get our data set downloaded. And the first is to select our output format, and we have two choices. We can get our global summary in a PDF form, or we can get it in more of a database form, a comma-separated value file, which we'll be able to open up in Microsoft Excel. And because the sales forecasting and rate model runs in Excel, this is our preferred option. It'll be a lot easier to work with, process and reorganize, and then get entered into the sales forecasting and rate model. Next, we select our date range if we haven't already. We selected ours, so we're just verifying, yes, we want 1980 through the end of 2015. So we're good to go there. We've got Chicago O'Hare, which is what we wanted. And so we click Continue. And we have a few more options to select. We can choose to have the station name. If we don't choose this, it'll just have an identifier, and we may not know that it is O'Hare, so we're going to put the station name. We could select the geographic location. I'm going to leave that off. And we can add any data flags if we want, such as if there's any missing days in a monthly reading, it would let you know that. I'm going to leave that off for the example as well. But I typically include that, especially if it's the first time I'm downloading data for that specific station and the same data. So I'm going to leave that off, and then we select our units, standard or metric. For this example, we'll go with standard, which will give us precipitation in inches and temperature in Fahrenheit. If you're in Canada or another location, of course, you could click metric and get metric. If you've used NOAA before, you might recognize that this is a fairly new feature. I think it's a few months that they've been doing this. It all used to come in metric, so it's a nice update to their website for these data sets. And next, we just select the type of data we want. We want two things. We want precipitation, and this comes in a variety of flavors, but we're just going to take the total precipitation for the month. And then we want temperature data, which is the average maximum temperature. So we'll click on maximum temperature, continue, and we just want to review and make sure this is all what we entered and what we want. It is. And our last step here is just to enter our email address and re-enter it to verify and submit. After you click Submit Order, you will receive an email fairly immediately indicating that they got your order. And then when it's complete, you should receive another email with a download link. You can also check on the status of your order through a link in the initial email you receive. So if you don't get an email pretty immediately after submitting the order, you might want to go back and check and make sure you entered your email address correctly. So that's all you have to do on the NOAA website, pretty quick and straightforward. And then you will get a download link, and you will get some data that looks something like this. It won't have columns widened like we have here, so it might be a little more scrunched. And it's just nice to get it organized so you can see what's going on. The first thing I do is take this CSV file and I convert it into an Excel workbook, and that allows me to make the changes I need to make and save the file accordingly. Once I do that, I add two worksheets, one for the precipitation data and one for the temperature data. So we get this, and it has our station identifier column, the name, which we selected to include, and we can see that it's Chicago O'Hare, the date, which is formatted in year, followed by a numerical month, so 01 being January, and then precipitation and temperature data. So that's it. That's what you'll get, one worksheet. And then as I mentioned, I like to process these separately, and I create a worksheet for precipitation and temperature. And of course, as we're going through this example, you may see things you would do differently, and of course, please do that. There are many, many ways to go about this. So let's click over to precip data. I basically just copy in the data from our original worksheet, and I deleted the temperature column to process just the precipitation data. And then I create a table that's more organized like the sales forecasting and rate model. You can see the data here that we receive is organized in a column, and it goes by year and by month all the way down to the end of the worksheet. But that's not how the sales forecasting and rate model is set up. It's set up with months going out in the rows, and then the years are organized into the column. And while we're on this worksheet, I'm going to enter 2015 as the most recent year for our weather data, because that's what we downloaded. And you can see that automatically changed on the worksheet. So going back to our downloaded data, we've got our precipitation data. We've got our table that we created that's a lot more like what's in the sales forecasting and rate model. The only difference being 1980 is on top instead of 2015, which is our most recent year. So one way you could organize this data is to go through each year and scroll down, highlight all the 1980s from January through December. I just clicked Control-C to copy, and then I'll come over here, right-click, paste special, and transpose, and that will paste the data out in a row instead of how it's organized here in a column. And you could go through the data set and do this all manually if you want. It's certainly effective. I didn't do that right, so I'm going to Control-Z, paste special, transpose. So you can see there's some pitfalls of doing it manually. If you do reorganize this manually, I would look out in your data set for possible missing months. So sometimes a month will be missing from a weather station. Say it's this one I have highlighted, which is June, and I might unknowingly copy 12 months and overextend into the next year. So it's just something to keep an eye out for. Weather data is not always perfect in terms of its completeness of the data set. This one, I happen to know, has every month for every year, but just something to keep in mind if you are going to do this manually. I'll click over to the temperature data worksheet and show you a way you can fill out a table just like this, but with a formula. So we'll click over here, and I added the data from our original data set and deleted the precipitation column because this is our mean max temp data. And then I added two columns, the month and the year. So I wanted to separate the month and the year that were provided from NOAA. And to do this, I used pretty simple Excel formulas, but they're simple but not necessarily commonly used. And this one I'm just telling Excel to grab the right two characters of this cell. So it's saying grab the two characters on the farthest right, which is the month. And then same thing for the year, but I'm asking it to grab the four most left characters in this cell. So that creates a month and a year column and allows me then to have Excel look up data based on the month and the year. So one thing different on this worksheet is I added a row to this table that entered the number for the month. So January again is 01, February is 02, and I can use that in my formula to populate this table. And I created this formula. It's an index and match function, and it's going to look up each year and month for me throughout this data set. So I'm not an Excel instructor, but you can create a formula like this, or maybe there's another function you prefer and think would work even better, and of course you can do whatever works best for you. I'm going to paste this out to the right and fill out all of 1980, and then I'm going to copy that whole row and paste it down to 2015. Now I've made all the proper precautions to make that copy and paste work. So if you do that with a large data set like this, you just want to make sure you've got your formula set up in a way that it can be copy and pasted. So that was very quick compared to the manual copy and pasting. And it also prevents the error I mentioned earlier about if there is a missing month, because it wouldn't fill in a cell if it didn't have a corresponding month and year. Right off the bat, after I paste in this formula, I noticed that the 1980 and 1981 values for January are identical. And this is a red flag to me, and it's something I want to audit, so I'm going to go into my data and look. And for 1980, January's value is indeed 31. And then for 1981, it also is 31. So this tells me the formula is working, it's functioning, but when I see values like that, it makes me wonder, and it's worth double checking. That said, it's good to go through a table like this and audit and check it against the data set. So we can do that as an example and check out September 1990. And what was that value? I clicked off of it. So we're looking for 75.7 for September 1990. We scroll down, and there it is, 1990, September, 75.7. And I would do that more than what I just did, but just to give you a quick look at using a formula like this and then auditing your results to make sure it's functioning properly and grabbing the data it's supposed to. So we've come a long way. We've downloaded a data set. We've already reorganized and processed the data, and we're very close to being able to enter it into the model. But as we know, in the sales forecasting and rate model, our most recent year is on top. So I'm going to paste in another table, and you might notice that I pasted this in as values, and that's because if I just pasted this down with a formula, it would likely have some problems. Although in this case, I think it would hold up the way it's structured. So now we need to sort this data. So we highlight the table, and we'll use the sort function and custom sort. And we're going to sort this by year because we want our most recent year on top, and that's in column H. We don't have a column heading for the year. That's okay. We can just say column H. We're going to sort by value, and we want to sort largest to smallest, so the most recent year is on top. And there we go. We've got our data set up exactly how we need it to be pasted into the sales forecasting and rate model. So I'll highlight the data, Control-C for copy, click over to the sales forecasting and rate model, and this is our temperature data. So moving back, we'll go to the temperature data section and paste that in as values again. You want to make sure you don't paste formulas into the model itself, although if you do, it's very likely you would get error messages, but just in case, make sure you paste it as values. So you would do the same thing for the precipitation data and get that entered in. As you can see, this didn't take very long, all the way from downloading the data to processing it. It's a pretty quick process. And then the last thing on this worksheet is to go through each year, and if your service area entered a specific stage of drought, you can indicate that here under column AD. So there's a description in the model all about that. So there you go. We've got our weather data downloaded, processed, and organized. And once we get that precipitation data in, we're ready to rock and roll with the simulation module, which I highly recommend you check out. It's a really cool feature of this free resource. So happy forecasting, everyone. Thanks for tuning in, and we will catch you next time.